So moving on, number 20. Number 20 is asking you what is too important to ignore when developing breeding plans and production systems for mammalian livestock. So we don't talk much about paternal heterosis because it's not there. I mean, it is there, but we don't worry about it that much because it's not as important as other things. Heteromaternosis, that's not even a thing. Direct heterosis and direct homozygosity, or let's go down to E, direct homozygosity. That we don't talk about it because it doesn't make a difference. That's just your breed traits, your breed effects. Direct heterosis and maternal heterosis. So now we got to determine between those two what's too important to ignore when developing breeding plans. And in Dr. Riley's video, his lectures, he mentions a lot that maternal heterosis is probably the single most important thing when looking at production systems. So that's why the answer choice here is A. So moving on to the open-ended question. Should be fairly simple if y'all understood what the questions were asking. So between these two bulls, which bull's daughters are expected to be heavier at maturity? So that's looking at mature cow weight. So which one has a heavier mature cow weight? And that would be this fast track or fast rack. Because he's at 107 versus the other one, Hot Shot, at 82. So fast track is heavier, and how much heavier is just the difference between the two, which is 25 pounds. Next, what's the probability that fast track's true transmitting ability for mature cow weight is less than 82 pounds? So 107s are EPD. And then you have to look at the accuracy. An accuracy of 0.3 gives us a possible change value of 25 pounds. So what's his true transmitting ability for mature cow weight is less than 82 pounds. So remember, when we're looking at how far away it is from the EPD, we can take our given value at 82, subtract it from 107, and divide it by the possible change value of 25, and that's going to give us -1, which says that it's going to be one possible change value away. So this is going to be 87, and we know that the distance between one possible change value plus or minus the EPD is 68%. So we can take and do 100 minus 68, and that's going to give us 32. So on both sides, possible change value is 32. But remember, we said that we're only looking at less than 87. So we're going to take 32 and divide it by 2, and that's going to be 16% for being less than one possible change value away. Moving on to the, number 3. Hot Shot is actually greater than, what's his probability of being greater than 107? Our given value of 107 minus our possible change, our EPD of 82, divided by the possible change value of 25, that's going to equal 1. So remember, that's just saying that if 82 is the EPD, 107 falls one possible change value away. So being greater than 107 is going to be 16%. So on number 4, y'all's test was if fast track's true transmitting ability for mature cow weight is actually less than 82, and Hot Shot is transmitting ability for mature cow weight is greater than 107, which of the two bulls' daughters would you expect to be heavier at maturity, and why? Or sorry, not why, and at least how much? And that was saying if Hot Shot was greater than at 107 and fast track was 82, we can say that Hot Shot 107, fast rack 82. Hot Shot would be heavier by at least 25 pounds because this is just saying if it was less than 82 and greater than 107, so it was at least 25 pounds. Number 5, if you use both of these bulls heavily in your herd and found that fast track starters were not actually heavier, use the probabilities that you just found and your knowledge you have about EPDs to explain why you should not be surprised by this unexpected result. All you had to do, there's 3 things that I said in my video over EPDs as to why this is not an unexpected result, or why you shouldn't be surprised. There's low accuracies. Young bulls. EPDs are estimates. So we were looking for something along the lines of those 3. Low accuracies. With the low accuracy, you have an increased possible change value, giving you higher, I guess, more variation in where the EPD actually lies. For the second one, young bulls. I'm not sure if we told you how old these bulls were or not, but that could be a reason as to why the accuracies are so low, because they don't have as many offspring on the ground. And then number 3, the biggest thing is EPDs are just estimates, and there's always error associated with the estimates. That's why we have the accuracies to explain how large the error is. So EPDs are just estimates. So since they're not set in stone, there's no reason for you to be surprised by this unexpected result. So